Before we start programming, there's a few concepts and terms that you need to know. The first is the difference between R and RStudio. So R is used to refer to both the programming language and the software that interprets scripts we'll be writing, whereas RStudio is the more user-friendly interface for writing scripts and interacting with the R software. So why learn R? Well, R doesn't involve a lot of pointing and clicking like Excel, and even though there's a high learning curve with R, the results of your analyses don't depend on remembering this series of pointing and clicking. Instead, R relies on a series of written commands, and that's a really good thing for reproducibility. It allows you to redo your analyses. And working with scripts makes the steps you used in your analyses clear, and the code you write can be inspected by someone else who can give you feedback and even spot mistakes. Working with scripts forces you to have a deeper understanding of what you're doing, and it also facilitates your learning and comprehension of the methods that you're using. So R is great for reproducibility. Reproducibility is when someone else, including your future self, can obtain the same results from the same data set when using the same analysis. And an increasing number of journals and funding agencies expect analyses to be reproducible. And there's a growing trend of depositing your R code alongside with the data when you publish an article. R is also interdisciplinary and extensible. The interdisciplinary part means that R is used across a wide range of fields from health and medicine to ecology and engineering. And it's extensible. What that means is that there's tens of thousands of packages that can be installed that extend the capabilities of R. Packages can be developed by anyone around the world, including you, and this allows you to combine statistical approaches to best suit your particular analyses or data. For instance, R has packages to analyze images, to look at population genetics, and anything you can think of. R works on data of all shapes and sizes. Whether your dataset has hundreds or even millions of lines, it won't make much difference. And R is designed for data analysis. R can also connect to spreadsheets, databases, and many other data formats on your computer or even on the web. R also produces high quality graphics, and we'll see that the plotting abilities in R are pretty much endless. You can use these to design artwork, you can use these to design kind of graphics that you'd see in the New York Times, and you can easily adjust your graphs. R also has a large and welcoming community. There thousands of people use R every day, and many of them are willing to help you through different mailing lists and online communities like Stack Overflow and RStudio community. R is also free and open source, and anyone around the world can use it. When you open up RStudio, you'll see these four windows. We'll use RStudio to write code, navigate the files on our computer, inspect the variables that we want to create or work with, and visualize the plots that we generate. So RStudio can be used for other things as well that we won't cover in this course, like developing packages or writing interactive websites. So the RStudio interface is divided into these 4 panes. The source up here for your scripts and documents, your environment here in the top right, which shows all the objects in your working space or environment, and we'll define those in a minute. Your command history, you can see a history of the commands that you've run, also up here in the top right. You can see your files, plots, packages, help, and viewer in this bottom right pane. What's called the console in the bottom left pane, and this is where the code actually runs. And one of the advantages of using RStudio over R is that all the information you need to write code is available in a single window. So we'll see we can look up help if we forget what a particular function does. We can see the code, we can see our files all in the same window. When we're getting set up, an important concept to understand is the working directory. We'll want to keep all of our data, analyses, and text like README files in a self-contained folder called the working directory. All of the scripts within this folder then point R to this folder to navigate all the different files. It's a lot easier to move around on your computer and share it with others without worrying about whether or not the underlying scripts will still work. And we'll see this functionality through the use of projects. Projects creates a working directory for you, but it also remembers its location, which allows us to move quickly to that folder. Let's see an example of creating an R project for this tutorial. I have my RStudio open, but I'm missing this pane up top. That's our script. We can reactivate the script by using this icon here, the green plus sign, and opening up a new R script. The first thing we want to do when we open up RStudio is to create a new project. So this is basically a new folder where all of the data, all the scripts that we'll use for this tutorial will be stored. Under the File menu, click on New Project, and we want to choose a new directory. So this is basically a new folder, then New Project, and we want to enter a name for this new folder. I'm going to call it Getting Started, and I'm going to save it in this subdirectory of data science, but you can save it wherever. And I'm going to select Create. All right, now I need to reactivate an R script. And now we can start coding. The next thing you'll want to do is download the code handout, place it in the working directory you just created. And I've done that already, and now it appears in this folder that I created, this Getting Started folder. And go ahead and open it. Our workspace is our current working environment in R. By default, all of these objects will be saved and automatically loaded when you reopen your project, and we don't want that to happen, so we'll need to turn this off, and I'll demonstrate how to do that. So let's turn off automatically saving this data. because it can lead to hard to debug errors by having things loaded in the memory that you forgot you had. Let's go navigate to Tools, Global Options, and select the Never option under Save Workspace to .r data on exit. So never. This prevents R from saving settings inside the workspace. I'm going to select Apply and OK. We also want to start out by organizing our working directory. We want to use a consistent folder structure across all of our projects to help keep things organized, and it'll make it easy to find or file things in the future. This can be useful when you have multiple projects or multiple assignments, like in this course. And in general, you'll want to create folders or directories for scripts, data, and other documents like the metadata. To do this in RStudio, we can create new folders for scripts, new folder for data, and a new folder for maybe figures. We also need another folder for our raw data. Remember, we want to keep our raw data separate from the clean data. We could also use R's built-in functions to create new folders. This is directory create, and I'm going to create a new directory or new folder called documents. And this is where you would store your manuscripts or the papers or the metadata. You'll notice a few different colors here. The function, this is called a function. It's in black. What's in parentheses is in green. And then these hashtags create a line that's also green. And we'll talk about all these different components in the next video. Let me run this. I've written it in the source code, but I haven't run anything. To run, I can select this icon, or I can put my cursor on the line, and on a Windows machine is Control Enter or Command Enter if you're working on a Mac. And notice how when I ran it a second time, it gave me a message notifying me that the folder already exists, and that's fine. The working directory is such an important concept to understand because it's the place where R will be looking for and saving your files. So when you write code for your project, it should refer to files in relation to whatever is in your working directory folder. Using RStudio projects like we did, we created a new project, makes it easy and ensures that your working directory is set up properly. So if you might get error messages. Let's see an example of an error messages. I'm going to do something like this so I can get an error message that says cannot open file, no such file or directory exists. That's one of the most common errors when you're first starting to working with R because of this working directory concept. The data is not in your working directory and you think it is, or R is pointing to a place where the data is not located, and by using RStudio projects, it guarantees that your working directory is set up properly. If you need to check your working directory, we can use the function getWD for get working directory. And we can see that the working directory is pointing to this folder on my computer, right? This is specific to my computer, so yours will look different. But notice how we're inside of this getting started folder or directory that I created as a subdirectory of my data science folder. But this part might be different depending on where you want to store it. The basis of programming is that we're going to write down instructions for the computer to follow, and then we'll tell the computer to follow those instructions. So we write code or instructions in R because it's a common language that both the computer and humans can understand. We call those instructions commands, and we tell the computer to follow the instructions by executing those commands, which is also called running those commands. So there are two main ways of interacting with R. One is by using the console here, like we did with getWD, or by using the script files like I did by selecting the run command. The console pane in the bottom left is the place where commands are written in the R language. They can be typed and executed immediately by the computer. And it's also where the results will be shown for those commands, whether you run it in your script file or the console. You can type commands directly into the console and press enter. I'll show that again. Get WD. Or up here, I could also write them up here and execute them or run that line from the script. The benefit of writing your scripts here is that you can save them for later. When you run a command in the console, it's not saved anywhere. So you'll lose those commands once you close the session. So because we want our code and workflow to be reproducible, it's better to type the commands we want in the script editor and then save the script. This way, there's a complete record of what we did, and anyone can easily replicate the results. It's important to note that in the console, if R is ready to accept commands, the R console shows this kind of Pac-Man greater than symbol. If it receives a command by typing or copy pasting or sent from the script editor using Control Enter or the run, R will try to execute it. And when ready, we'll show the results and come back with a new kind of Pac-Man prompt to wait for new comments. If R is still waiting for you to enter more data because it isn't complete yet, the console will show a plus sign. Let's see an example of this. So let's say I ran this with Control Enter, or let's say I ran this one line here, and you notice that my command isn't complete. There is this hanging comma and the parentheses isn't closed. So this would be a complete command, right? We have a function, an open parentheses, and a closed parentheses. And we'll need to do those accounting. We'll see how to do that accounting in the next video. But you can see how R is expecting additional code because of this plus symbol. So I need to provide it with the rest of the command. And in this case, right, it won't it will keep giving me that error message because this data doesn't exist in my working directory. All right. So what happens if you get in that mode where R is waiting for more data and you don't realize it, and then you try to give it another command and you'll just perpetuate these plus symbols. So to get out of this, right, I'm continuously pressing enter. To get out of that, you can press the escape. And now we've gone back to this Pac-Man symbol that lets us know that R is ready to accept commands. Using R is basically being able to use Google, because no matter what you're doing, you'll want to look up the function or an example and modify it to what you're doing. There are several ways of asking for help when using R. The first is this built-in RStudio help interface to search for more information on particular functions. We'll see an example of that. The second is Google. Whenever I'm coding, I have Google open and I toggle between RStudio and Google because I'm always looking up, how do I do this in R? So you'll want to search for how to do a particular thing and add in R. You can also ask for help on online communities like Stack Overflow, and there's some recommendations for how to ask for help in Canvas. You can also use these recommendations to ask for help um, in our Canvas page. So let's say we want to calculate the mean of a variable, but we don't remember what the function arguments are. We can use this question mark symbol followed by the function name to look for help on that particular function. So it'll provide you the usage, what are the different arguments, so those are the things that go inside the parentheses. And we'll learn more about this in the coming weeks. What I particularly use the help for is to copy and paste the examples into the console, and I can see how this function is used, what the arguments are, and I can modify it for what I'm doing. So a lot of programming is changing stuff from an example and seeing what happens. And I encourage you to find examples online, play with them inside of your RStudio session, change variables and see what happens. You're not going to break anything. You're not going to break the program or break your code. And it's good coding exercise to find an example, copy and paste it, and kind of, start changing things and see what happens. I'm going to run this line of code, or I'm going to change something and see what happens. If all of this looks very new and unfamiliar, of course it does. You've never been exposed to this before, and that's why you're taking this class. So in the coming weeks, we'll go through what all of this notation means. And by the end of the course, you'll be able to understand a completely new language. Learning R is like learning a new language like Spanish or Mandarin. All right, at the beginning, you don't understand the words or the pronunciation, but by the end of this class, you'll be able to understand what this means. And that's exciting. I'm excited for you. I'm going to end with this quote: "A little learning is a dangerous thing." I know it all seems new and maybe overwhelming, but don't worry. By the end of this course, you're going to be amazed by how much you were able to learn. And even if you come away with the fundamentals of how to use R, I want you to feel comfortable using R and looking up how to do things in R. If you can do that, then you'll be set for the rest of your career. In the next video, we'll cover some of those fundamental syntax and vocabulary for programming in R.